Welcome, judges. We are Team 19 and we're focusing on the public services case. Our solutions include finding comparing the maximum and average occupancy rates, analyzing change in occupation rates over time, the general heat map analysis, and in-depth strain analysis. So to start off, we want to compare the averages and maximums of different, programs. So sector, program area, overnight service charge, and capacity type. From the blue table, we can see that the sectors with the most problems are men, families, and women, and the difference between their maximum occupancy rate and average occupancy rate is less than of for mixed adults and the youth, which gives them less leeway to react to shocks. And so those are the most vulnerable sectors. For youth, we can see that it has the highest difference and will have the most resilience to shock. Looking at the other three tables, we can see that programs that allow for a broader population to be sheltered, for example, the 24-hour respite site tends to have a rate over one more frequently. And so in the long run, we should focus on investing in resources into those shelters that allow for more people to come in. Moving on to comparing totals and rates over time, we can see that men hit an occupancy rate of over 1.6 times and women do so twice, and mostly in the summer months. And so we should find why that has happened. Comparing the number of counts that sector men, women, and families include in or pop up in the rows, we can see that men is 30% more than women and around double of families. And so the population of men that are homeless is much more than women and families, and they also hit the maximum occupancy rates more frequently. And so we should focus on the men's sector the most in the short run. And this is again reinstated in the three aggregate tables. We can also see an increase in variability in 2025, and so this indicates a shock. Look at the rates over time, we can see that the occupancy rates again lower in 2025, and so again indicating that some sort of shock may be helping the system become more resilient. And this is again reinstated with the occupancy rates by sector over time. And so overall, we should target shelters that allow for a broader range of population to be sheltered. And we found out a way to measure resilience by seeing the difference between the maximum and average. And also we found that the youth sector is the most resilient, while the men may need more attention. And we want to monitor the shock in 2025 to see if it's an effective way to decrease occupancy rates and make the system more resilient.
So other than by sector, we can look at the overall occupancy rates over time by other features. So on the left, we are grouping by overnight service type, and on the right, we're grouping by program area. We can see that on the left, search sites consistently have lower occupancy rates, and on the right, winter programs have the lower occupancy rates, while we can see that motel and hotel shelters and temporary programs are consistently very close to a capacity of 1. So the types of programs and shelters with higher overall capacity should be focused on more, especially temporary programs, which may be used to contain overflow. We can also create this measure of fragility with measuring standard deviation. So we're defining fragility as the volatility in the amount of resources, and by that we mean this unavailability ratio, which is a metric defined between 0 and 1, kind of measuring how many beds or rooms are unavailable at a shelter on a particular day. And we will take the variability of this unavailability ratio over time for each shelter. Then, as a result, we can see that this variance or standard deviation tends to be higher for men's shelters, as well as winter programs and temporary refugee response. So this indicates higher volatility in the resources provided for those programs, so they may require more attention.
I'm going to go over the heat map analysis now. So the method that we use is to cluster the services using k-means clustering. And what this found out is that higher cluster, and we were able to find out that the capacity has the highest impact on this numerical data. And so with that in mind, we assigned the higher cluster IDs to the greater capacities and which have more occupants. We also decided to index the heat maps on the occupancy rates to see any similarities between the data. And for example, we found that in temporal data, it looks generally quite consistent throughout the year, but it has a bit more saturation in the winter months. So that means the winter months see more occupants in the services. This is also being reflected within the occupancy rate heat map. As you can see, we have a more saturated bar for the winter months. You may have noticed that it is a bit less saturated. It is a bit more green for the occupancy rate of 1.0, but overall, the other occupancy rates do have higher saturation than the other months.
So now finally, we might ask ourselves, how close are we to the breaking point? The answer might not be optimistic. Let's define some metrics. Firstly, strain takes into account the occupancy rate of each shelter, but also the unavailable occupancy, which can signify the system's incapacity to respond to certain events. Resilience, on the other hand, considers the health of the system as the average proportion of shelters with less than 90% of strain capable of responding without immediately breaking. Analyzing the score distribution, we see that the system is indeed at capacity everywhere and in every sector. This is actually due to mostly very high unavailable to available occupancy ratio. We are observing an increasing trend in resilience, though, especially between 2024 and 2025, though the numerical values themselves are low. When we simulate an incremental demand surge, the already fragile system does not seem to be able to take more than a 5 to 8% increase in occupancy demand, as a 10% demand would trigger a 60% collapse in resilience. The breaking point is therefore almost immediate. While the ideal solution is capacity expansion, it is equally important, if not more, to investigate the reasons for high unavailable occupancy count. Some shelters have up to a 106:1 ratio in unavailable occupancy to available occupancy on certain days. Available physical space without actual capacity to act as shelters debilitates the system, as it can signal the system's unreadiness to react in response.